So yes, for everyone tuning in today, we'll be kicking off this is the first, I guess, call or session of the DKG Zero to Hero. Right now, everyone but Branimir, we're all zeros and we're all going to become heroes. um, so, so if you're a complete beginner to, an experienced dev, this path is really here for you. Because what my aim is to become a dev myself and learn from these great pioneers. And I said, if I'm going to do this journey, I should do it in a way that everyone else can follow along with my journey so that we can just make more devs with whoever wants to follow along the path. So would be your pre-origin trail background. Pretty much before you got into dev work or working at Origin Trail, what made you go down this path? What were you like? What were the things you were interested in? And can you talk more about yourself?
Sure, cool. Again, thanks for having me, man. And yeah, it's the first time I'm on a session like this where people ask me about me. So feels exciting, weird, good, I guess. But yeah, how did it all start? I was kind of always interested in like generally tech. And when I was a kid, I learned relatively early to like some basic coding. I remember my dad, who was like, he's a mechanical engineer. But when I was like, I don't know, third grade or something, we got our first computer, and he showed me some simple things like printing out some things on screen, whatever. Got really excited about it. Also got excited about music, so I got some software and I started exploring and basically learned how to make music on the computer. So, it started with play, and then I got really good in high school. I was actually going into competitions, again, not like winning them so much, but doing pretty well. And then when I went to the university, I basically went to electrical engineering because the idea was to sort of broaden this scope. And actually, I made kind of a weird choice then. Like, I got a little fed up with coding at some point. I was good. I was even doing like some stuff on the side as a freelancer or my whole studies. But like, I got some really excited about networks. So I actually chose the telecom, how do you call that, major in electrical engineering. All kinds of things, cellular networks, old school LAN, Ethernet, right? So we learned a lot about these things. And if you look at the internet stack, the OSI 7 layers stack, this is like generally coding all of the things we do with blockchain. That's kind of in the upper layers. And we also went into the lower layers, which proved actually really instrumental since we all, I guess, are now in this journey of building OriginTrail decentralized network. Knowing all of these networking things meant a ton and actually gave us confidence to go in that direction. So I actually majored in telecom, and my first job was in this space. So I was actually working for a company, a German company, which is its job is to really help network operators around the world, everywhere, to make the best out of their mobile networks. And that was Verizon, Vodafone, all of these, the biggest ones. And my job was to actually analyze a ton of data collected on a daily basis, and to actually organize it, databases, right, and then propose optimizations for these networks. So you can imagine this. All of this was really super valuable for our journey for OriginTrail. And then in parallel, like I said, I was freelancing all the time with Tomasz and Giga. I met like a while ago, and we started doing some things together. We did the first OriginTrail while I was still in this previous company, and it started taking off. So it was kind of a choice to make, like, do we go in this full in or all in or not? And of course we did, and it was the best choice I ever made. So yeah, I think that's kind of a very short summary. I had like this journey into telecom, which at some point I was like, was this the right choice to make? But now after all of this experience, I think it was, because I have a bit of a different angle on computer science in general and engineering in general, because of a bit of a different set of problems and obviously education than your usual dev. So maybe the things that I will be speaking about today are a little bit unconventional from what like people would normally say. But yeah, take it with a grain of salt or whatever. I'm gonna try to give the best advice I can on the journey of yours and your folks.
Gotcha. Well, I guess you have extensive experience working with large enterprises and their their networks per se. I mean, so you brought all of that expertise to OriginTrail so from the inception of OriginTrail, it already had that level of expertise via your past experiences. Interesting.
Yeah, I mean, it was really valuable to go. Even before this, I was in an internship in a major telecom operator here in my home country, Serbia. And going into these systems helps you, like just being there for a while helps you to understand how they operate. And it's really good because when you go into an enterprise, which is kind of like think of a huge building with a lot of offices and people in them that somehow have to interact. Everybody has like some sort of area or small part to do in this whole big thing. Understanding the dynamics is kind of like understanding the dynamics of software. Software is usually composed of small parts, but like how it all works together, you kind of have to have that sense. I think organizations are a lot like software in many ways. You need ways to organize different groups of people, the same way as you organize different functions, for example, in your or even services if you're doing something like microservices in your code. And it's really good because then you realize, that you really need to find the right person for the right thing. And if you want to get something through, like for example, you want to adopt some new technology like OriginTrail, you have to speak with the right people, you have to know how they think, and you have to help them get this through, because this is not, quite often you're not speaking about super innovative companies who understand the newest tech. They can even be afraid from it. So you need to understand how to approach and say, hey guys, this is something that will, do all of this good stuff to you, and we know how to do it.
Thanks for the context on working with enterprises. I figured that would be very important for people to at least hear about, because I mean, let's be real. 90% of us in crypto, we have no idea what true enterprise like Vodafone and all these different companies look like, what they operate like. So when you guys say partnership coming, or we're working with this or whatever, it's just very abstract. So now people will be able to see, understand what you guys are doing and how this actually works.
Yeah, perhaps on that note, while you say it, like you see a lot of announcements, people speaking around like this and that, but I haven't seen a lot of material stuff. Like for example, the NOS. The NOS has been built in mind with this interface towards the enterprises, and the NOS is being used by a lot of the biggest enterprises in the world, like Scan, the Swiss Railway Company, all of those, Walmart, Target, and the likes. And for them to use it, it really needs to be packaged in such a way that it can service them, and from a UI perspective. But also there's like a ton of things under the hood that you have to do, which are really technical. For example, you cannot go, there's like a lot of really strict procedures if you want to provide, let's say, BSI, the British Standards Institution, your software. They have certain committees of technical people that review what you do, and they do code review. They review our architecture. It's something called the Architecture Review Board, which we had to obviously do many times, and the process is long. And obviously, these are some checks and balances of how they protect systems, So whatever sort of the idea you might have, it's actually very long. It's a lot of hoops. Those fiery hoops you have to jump through. That's kind of the enterprise thing. But once you go through all of them, your software is legit and kicking in the right things. So that's where, for example, NOS has had to be. NOS is what OriginTrail looks like to enterprises, packaged up in such a way that when they use it, they don't see a lot of the complexity is available. They can query them, they can share them. They can do what they're wanted to do. And then all of these complex things that they don't necessarily need to know about are kept under the hood. So that's the interface towards them.
In your early days before you got into OriginTrail, what languages did you focus on in your early days of your dev path? and then later on we could talk about like what you got into in terms of your developer experience. But what was early for you? What was the first things you started grabbing onto?
Ooh, okay. Yeah, so C was probably the first really powerful thing I was working with. It's been a while. C and C++ to an extent. And then I kind of did all kinds of things. So we played around from both like your classic computer science projects to stuff like signal processing. For example, I was building actually some filters in C for audio. So we would use the sound card as like a input, and you can process it kind of like you can process it in some sound application like kind of Cubase or something on that from Fruity Loops, whatever. Well, I built some adaptive filter back in the day. So there's a lot of fun things you can do with C, but it's very low level and it's kind of hard. And then when you go to, then of course JavaScript was something that kind of everybody catches on at some point. And then I guess Rust is somewhere in between, but closer to C. Python was also something I did a bit while at this company. Python was quite important. Shell, you always need like something to automate. Calvin knows, right? and yeah, I mean a little bit of Perl back in the day, not in a while. Solidity then, of course. But the languages, I feel they are important, and however, if I were to tell somebody like where to start from, I wouldn't so much focus on a language. Like if you're a newbie and if you just want to start coding, a great place to start is something about algorithms and data structures. So you understand actually what you're going to be writing about, because the language is really more like a tool, and tools come in different flavors. I don't know, you can consider a car, for example, a tool, and a van can also get you to another place, but like a van is more like, I don't know, C is like your van. You can fill a lot of things up and but it doesn't look nice, it's not a Ferrari. And, so in a way, like there's different types of tools, but they all like, in the end, you are the driver. And if you don't know how to drive, it doesn't matter what type of tool you have, right? So I recommend people who start out with something relatively easy. And when it's visual, it's probably even easier. For example, if you start with JavaScript and playing around a little bit in the browser, it's going to be at least more exciting than like starting command line C or shell, because if you're not excited by that from the get-go. And when it comes to power, again, different tools for different things. I'm the kind of person who is a little bit on the different foot than most people who generally like to bash JavaScript. I think it's actually a very good tool. It's not perfect. It's not for everything, but it has its advantages. And it wouldn't be so ubiquitous if it wasn't useful. Then again, we use Node.js to build a client for the DKG. That's not going to be the only client, by the way. And I don't mean just the DKG client, I mean the node. All of those speaking on the same protocols, they don't really have to be tied to a certain language, but you got to start somewhere. And this gives you the ability to iterate quickly and to do things like, for example, light nodes. If you build a JavaScript node, you can quickly port it between the browser and non-browser version, right? So there's a lot of advantages to it.
So I think well, I guess you got a degree in computer science, so you definitely focused on data structures and these sort of things via your official education. But for people who are just like on the outside, other than of course reading books and whatnot, what do you recommend to really get a grasp on data structures and algorithms?
I was a lecturer actually at the college here, so I knew a couple of really good resources. I could actually look some up maybe just to see if like what are the newest versions. But what I found useful for people, because I kind of had about 100+ students that I worked with, and from all kinds of ages and places and educations. What people tended to resonate well with was there was a specific JavaScript jQuery course by some guy named Jeffrey Way back then. I suppose the guy was really well in explaining things, but like he would start like with literally zero experience, and he would build it up actually quite fast. So Jeffrey Way jQuery, but that was like 10 years ago, so it's definitely not the freshest one. But I think people respond very well to video, and then obviously like examples right there. The big thing about this though is that when I say algorithms, like you can grab a book on algorithms, of course, but it's more like kind of like finding the best media type you like. Some people just like reading from books. Somebody's gonna go to video, Udemy, something of that sort. But the core message I wanted to say was that if you know how something works, an algorithm is just like a recipe. You're making pizza tonight. There's a recipe you follow, right? And then after that is you've done all of the things like, I don't know, make the dough, put the stuff on top, put it in the oven, wait for whatever, half an hour, get it out. I don't know. Like you can see, I don't know how to make pizza, but long story short is like this is the algorithm. This is just the recipe of how you do things. And then obviously there's more complex recipes like what if this, then do that. But like once you kind of get the grasp on that, it's actually relatively easy to start writing things. Now, obviously not super complex. Then you get into the territory of patterns. Patterns are really good. For example, a very common one is called the MVC pattern, Model View Controller pattern, which is kind of common. I guess every developer should know about it. And then when you get into these patterns, this gives you like kind of a custom language to speak with other people. Because if I come to you and say, hey, we're going to do this with, I don't know, the repository pattern, if you know about this pattern, you will understand that very quickly. I don't have to explain it for like an hour. So that's kind of a thing where this would make sense to go. But like when it comes to specific resources to start with, I can do a little bit of lookup, but like I would suggest something which is visual. You can rewind it, you can try it, and definitely try it. Because one thing I've seen from a lot of friends who I know, and I think a lot of people, at least around me, are trying to move from something to software development. A lot of times I would see that, for example, you play a video on your screen, but you're not trying to recreate the type, to do this on your own. It's kind of like math. You're in school, everything seems like you understand everything. You come home, you try to do your homework, and all of a sudden you're stuck, right? So you have to do the legwork or finger work, really. You have to type, you have to try. You're going to get stuck, many times. And this is the journey. It's like the hard part is not learning the commands or the syntax of a language. The hard part is, sort of getting all of this soaked in terms of like algorithms, but also like what to do when things go wrong. Because ultimately, one of the hardest things about software development is the difference between this and, let's say, creating some sort of a report. Let's say maybe you're like a consultant and you're creating a report. However complex the journey to make this report was, and maybe it's really impactful, I suppose it is. The difference between a report and software is the report doesn't. It's kind of fixed. I wouldn't say dead, but it doesn't do anything. It's like a piece of paper, and your software needs to work, and it should work with high reliability, like 99.9% perhaps. Many different occasions that you haven't maybe thought of. So you kind of have to be able to go to sleep at night knowing that, oh, I built my software right. It's going to be working while I'm sleeping. So it's. To get there, you kind of have to make a lot of mistakes, and that's why you need to type. You cannot just watch.
It's like how I put it in my head is like you're developing muscle memory. Because when you're drumming, there's stick patterns. You can read a stick pattern, right, left, left, paradiddle, but you know that. Of course, you know it in your head, right, left, left. But as soon as you start doing it a little bit faster, all of a sudden you can't do the same motion, because your body hasn't remembered it, right? So I think it's a lot like that when you're learning to code. You can understand a lot of concepts, you can regurgitate a lot of code just in your head, but when you sit down to type, it just is different.
Yeah, and that journey keeps on going. For example, when we built the first OriginTrail, like I was the only developer in the three of us, right, in the team, and so I had to do the best I could. And I was really good in SQL and databases generally. That comes from this experience in telecom because we were processing a ton of data on a ton of KPIs, like download speeds, all kinds of things. Basically telemetry. What we have telemetry for the DKG today, it's very much inspired by this experience. And we had to put all of this in huge databases. So I built the first OriginTrail under the hood. There was a SQL database, centralized, and then it worked for the first case. And then we wanted to introduce a different case, so we went from dairy to vegetables, which is not just milk but multiple different vegetables. It was like, oh crap, we need to change the data model. And very quickly you learn that if you change the data model, which is kind of like, or really the database structure, which is kind of like at the bottom of your app, everything is layered on top. Like all of this logic and the UI and everything is like, if you change everything underneath, you have to change something above, even if you separated it really well. We did the change the database in such a way that looked very much like graphs. And then after a bit of tinkering around it, we realized it doesn't scale. SQL was no longer the right tool. And it was actually quite a big problem. So in order for this software to scale at the time, doing a graph type of system in it was not something that could sustain itself for years. So that's where the actual graph databases came in. And the difference, for example, here is that graph databases connect things immediately. So if you're exploring these connections, it's much easier, while SQL keeps things in tables. So every time it needs to connect these things, and this connecting of things is an expensive operation. Long story short, you need the right tool for the right thing. But it keeps happening. Like you start learning, and then over time you keep learning. You're just learning on a kind of a different level. Same with blockchains. A lot of people, I've seen people try to use, for example, Hyperledger Fabric as kind of a distributed database. And yeah, you can do it, but it's super slow for that. It's not built for that. It's the wrong tool for the right job. But I guess we all keep learning all the time.
No, I think you're raising such a good point because as through my studies, I'm looking at data structures and algorithms myself and realizing that blockchain is like it is a glorified linked list, but linked lists have their own traversal issues. You can't just I guess recall data or do certain things with a linked list that you can do with a graph data structure. Graphs are just designed to do certain things better. And once you understand, I mean, that's like what you read a chapter or two, you understand that you can see the vast difference between what OriginTrail is, what a graph database is, and what blockchain is. Like you can just see it like right there. So I think that your advice is so spot on that I can't even I can't say anything else. That just is what it is. It is the correct path to understanding what you're working with. We actually answered quite a bit of the questions as well, because we talked about what you thought would be considered an important skill set for a dev to have. One thing that I did want to ask you though, you mentioned C and JavaScript and all these different languages that you worked with prior. How deep were you into these different languages? Like for example, when you were working with C, could anybody look at Branimir and say, okay, if there's a problem with C, we know Branimir can solve it? Is that how it was? Or were you just like, I'm getting by, I kind of can piece things together, but I can get the job done? What was your level of comfortability in your dev skills at those points? Even when you were at Vodafone even, like how did you feel about your skills?
That's a very good question. I think, it changed depending on the situation, of course. So you jump into a new language, all of a sudden you're not as confident as something you've been working with for a long time. But yeah, for example, for C, I was really, really good. I was the go-to person for that in some places, and at some point I got really good into Python as well. And databases generally. So But this confidence comes from like doing a lot of work and then actually having the opportunity to tackle some bigger challenges. So you have to be in an environment, if let's say you're starting your journey and you wanna become a strong dev, if you're in an environment that people sort of spoon feed you tiny small tasks and they're not challenging, then okay, maybe you'll feel confident, but you're not really growing. And at some point you won't get this confidence for real because you will encounter some problems that you're not able to solve. And so a healthy dose of hard stuff to do that sort of gets you out of the comfort zone is really absolutely necessary to grow as an engineer. And that's where you get this thing. And usually, I think, what was the name? Kind of like Dunning-Kruger effect. You know that thing? The effect says that like people who know less about something are usually more confident that they think they know. About like some probably know some random conspiracy person who simply oversimplifies things and they're like sure that like this conspiracy theory is right. Yeah, birds are not real or something like that. But anyhow, the same kind of goes with young developers. Like if you're a young developer and you get a little bit of this sense of power, oh, I can build shit. And then you get into a little bit of a harder task, all of a sudden you realize, oh shit, actually I'm not doing so well, because you started somewhere and then this is completely normal. Actually, everybody goes through it. So whoever on this call or ever listening to this, maybe if you feel like that and if you feel you're a little bit out of place, just keep going. That's completely normal. And not just normal, that means you're on the right path because you're growing. If you're doing the easy shit, you're not growing, So this is really key. And then what actually happens is some people pick like, let's say, a language and they grow and then stay at some level, which is probably a very good level, and they become experts in a certain thing. And some other people, and I generally consider myself as that type of a person, I don't stay on that particular thing. I start moving around more, see what else can be done. And that also is a little challenging because you constantly have to learn. I think there hasn't been a day in the last 5 years that I haven't read at least a couple of pages of some scientific paper every day. Because at that point you start realizing, okay, there's problems that we need to solve that nobody has ever solved. So there you go.
Every day?
Yeah, I mean, for example, for the DKG V6 right now, there's a bunch of things that we haven't even spoken about, like we just didn't have the opportunity, that are coming down the line, that are going to be very revolutionary based on not even bleeding edge research that others did. It's like what we did. And if we had more time, we would even write papers about it. But I feel more confident about building it and and using it, and then maybe others can write papers about it. I'm not against papers. It's just like there's not enough time in this in this life to do everything. But for example, the hashing, right? We use hashing of graphs with a Merkle root, and not to go too technical, this is super useful because you can not only verify the integrity of information in the graph, you can also verify that a piece of a graph is part of a larger graph. So if you create an asset which is like really big, you can prove that a piece of it is actually part of some data set. Maybe you only want to reveal a piece of it without exposing the rest of the data. So that's very useful. But this hashing has a property that every value is random. So randomly throwing data about assets around the network, which is a desired property in this case. But there's another really cool property. It's actually something. So imagine organizing data across the DKG, not by randomly distributing across the hashes and then having this property of verifiability, but actually distributing according to similarity, so that similar things end up in the similar regions in the network, so you can do more advanced search. Similarity search, for example. And then going even further, you can go into AI-based search, based on vector search, which is what you can see, for example, Facebook doing. And based on V6, we will be able to do exactly all of these things. So we can kind of grab that tech that they built and open source, thank them, and we can just apply it. But like obviously, we need to know how to apply it. So these are some challenges that haven't been solved in a distributed, or even better, this decentralized manner ever. And we're the first ones working on this. So getting there, you kind of have to be confident with like, you know, your C or JavaScript. So I guess that was a very wide answer, but I think it's a choice. You can choose to be very good at one specific thing, or you can choose to be like I believe the polymath is the word in English, I guess, which I think good engineers need to be. There's no protocol engineer or really any software engineer in Trace Labs, which you cannot give a random language. Like, I don't know, we can just say PHP, for example. People can take it and very quickly be quite proficient in it because of the skill set, because very vast experiences in data structures and algorithms are there. So you quickly transition, you know. And I think that's the skill of a real engineer. If you only know one language and you're not like able to port to another place, it's more of a how do you say this in English? Like it's more of a technician rather than an engineer. You can do things in one language, but you're kind of like, you know, you can do this one thing. But as an engineer, you're able to build, and in that sense, you can build anything. So when you have that skill, I suggest like, you know, going that way, it will empower you so much more.
So can you speak to that? Is that true to you? Have you seen like working with graph data structures to be any more difficult or anything than working with any other form of data structure? And let me also say, I feel like if you're doing enterprise work for Vodafone or you're doing enterprise work for OriginTrail, I mean, it's still enterprise work. So it's hard regardless. But if you could speak to that, maybe you could talk a little bit more about working with graph data structures.
Yeah, I think the reason, so graphs are relatively new. Like if you look at the first graph databases, they kind of showed up about the time when we discovered them. So more than 10 years ago, like, okay, there was the notion of the semantic web and there were standards emerging, but there were like the notion of a graph database was not there. Like semantic web is a bit different. It's like the notion of the web. We don't observe the internet as a big database, right? But so Tim Berners-Lee went into this, his Web3 was the semantic web, right? But it's not a database. So then this is quite a new field for databases, and that's why there's not a lot of, as many developers, let's say, or model resources as you would find for SQL or something that people are used to, or even things like NoSQL, like Mongo, for example. And then the complexity part is, well, it's kind of relative. There's a lot of obviously complex graph problems, but there's a lot of not that complex graph, like just like a database. You can use it for like different things. About folks trying to build, more than 10 years ago with MongoDB, they tried to build a distributed social network called Diaspora. And the very, very capable, very experienced engineers tried to do this. They ended up having a really complex, they couldn't join data across the entire network because, like, you know, you would use a Mongo record pointing to some other records, and then these records, who knows where they were, and like it was a little hard. Like I'm simplifying here. If somebody's interested, you can look up Diaspora. And I think the article is called "Why You Should Never Use MongoDB" or something like that, which is not true. You should use it sometimes. But like back to graphs. Graphs are you can do a lot of things, even simple, without like super high math knowledge, you know. And of course, you should pick them for the right problems. I wouldn't say they're that much harder. Now, if you go to, let's say, something like graph neural networks, which is like machine learning, AI domain stuff, of course, that's going to be hard. But fundamentally, graphs, if you look at them from a mathematical perspective, they're not that complex. Or they're just a different type of a paradigm to observe data. What's great about OriginTrail, you don't have to even see the graphs so much. With this new version of V6, you're actually able to use simple JSON. Now, it has limits when you use JSON. You cannot do everything that the graph can do. But like a lot of the things you can just do with JSON, and then this JSON under the hood gets converted actually into RDF, and it becomes a graph. The complexity of this graph is a little limited when you use JSON, but like if you really need to go like complex, you can always just use RDF in some format on your own. So yeah, I wouldn't say it's super complex. It's just it's another tool, and you can obviously learn to use it in better ways and or not. What's great about graphs is that you're actually getting into kind of a realm where you can do some more interesting information retrieval problems. This domain information retrieval is generally like the computer science domain that you would fit, like, let's say, Google in, you know? Google is all about finding things where they are on the web. OriginTrail is about finding things in a very similar way, but in a different environment, right? And then with that, actually emulating a lot of the things Google does. But like when you think about it, your internet before search engines was like, everything was there, but it didn't matter so much until you could find it, right? There could be like an amazing website, but you cannot go there, or you cannot see Amos's channel because you won't find it anywhere. So they're the glue of Web 1 and Web 2, and very much so on Web 3, we will need this. And graphs are perfect for this. You know, if you want to connect different things and align them with some either keywords or similarity search, or this even AI-based search, as I mentioned, vector-based search, you kind of always end up in this area to use graphs. Maybe not only graphs and some additional things with them, but generally they're like the spot.
There's one time you mentioned that we'd be able to upload images to the DKG. Now, right now, we know that we're doing JSON, and if you're linking anything, you'd have to like link it from an external resource like IPFS or something. So a friend and I, we were looking into encoding images into JSON, so you could literally pass an image via the JSON itself. Is that so? Will people be able to encode images, right, and then issue these assets as DKG provisioned NFTs, but not really anchored in a particular smart contract? But it is, because you can't really do anything with that asset without having ownership over the graph state. So how exactly do these things work together?
Yeah, it's very interesting. You touched upon a couple of things. I'll try to go step by step. So when it comes to pointing to something like with a URL versus hosting it directly in the graph, both cases will probably be used. Now, at this moment in time, images, you cannot squeeze that so easily in. You can, like by base64, for example, you can encode an image. But the point is that at some point, if this is useful, it would not be that hard to implement, to add both images, video support. The question is to see what type of case this needs. For example, if you're pointing to a YouTube video of yours that's already on YouTube and you want to direct attention there and collect views there, then obviously it doesn't make a lot of sense to upload the same video on the DKG, right? But if you're doing something on the other direction, if you're creating an asset on the DKG, that part of this needs to be this video for some reason. Maybe it's already part of, because Web3 is all full of great innovations. So if you're creating let's say, some sort of animated or modular new NFT type of an asset that's used in a game, let's say Web3 game, you wouldn't kind of want to go to YouTube to fetch that piece of content that you need. It makes sense to put it in a decentralized network, and the idea for the DKG is that we add support for such things. So not just RDF JSON stuff, but also like basically add this. And the point here is that you have options, and then with these options, you can really exploit the power of existing Web 2. For example, the power of, like I mentioned, YouTube or Facebook or TikTok. You could create, I don't know, TikTok is all the rage, right? You can create an asset on the DKG that is basically an extension of your TikTok video. And you could direct traffic if that's an interest to you. Let's say you're an influencer and you're all about views on, I don't know, TikTok, your DKG asset can be another window into it, so directing you there to the video, but also be a very natural Web3 extension to it. So all of the things that don't come with Web2 can be in your DKG asset, not just the actual ownership of it, but also the all of the potential extensions and basically opening up this world to all of the smart contracts. And that's where you mentioned the tokens, and so it's that the other part of the question, let's say, apart from this Web 2 stuff, where we've seen a lot of interesting things. For example, we've seen a lot of G can become a decentralized sort of a collector for all of these assets from different platforms with all of the properties of the graph. Now your question was a little bit wide.
It was very wide. So it was a multi-part question. I asked you about the encoding images onto the DKG, basically owning those token, the provisioned assets, without having like a smart contract.
NFTs. Yeah. So you can observe from the DKG perspective. This might be a bit confusing, so I'll try to clarify it now. A video on YouTube or TikTok or NFT that was provisioned through Instagram, for example, and let's say Bored Ape NFT, all of them are something that you can refer to with the DKG. So these basically get into as an asset that your DKG asset can point to. Now, the implementation of the DKG asset also contains its own NFT, and that's only used really for the implementation of ownership, but also, as we didn't want to implement this like just some random way, it was best to pick a standard and then open up this entire new possibility of basically all of them being native NFTs. So when you provision an asset on the DKG, you get this asset graph, which is all of this graph stuff, and you get an NFT and they're interlocked cryptographically. So this NFT, if I want to sell my asset to you, I just sell an NFT to you, and you have this NFT, I can transfer it to you. And implementation-wise, you get it, and then all of a sudden you have the ability to edit the graph because this is yours. So you own literally pieces of the graph, and this is implemented by NFTs. And does this can also point to other NFTs or other assets. So that's where it gets a little bit.
So you are getting you're getting an actual NFT.
Yes.
Which has the asset graph data. So you're transferring an actual ER721 actual NFT, but it represents, it has the graph data which you can then control because you have ownership over that particular NFT. And you only get this NFT once you've provisioned via the DKG.
So yes, when you create an asset on the DKG, what happens is you have the first transaction, that is the create transaction, mints an NFT, creates a UAL, and then with this transaction basically and this mint, you become the owner of the NFT. But also it stores this Merkle root. It also is used to give signal to all of the nodes in the DKG network to understand, I'm getting a request to host this asset graph. Does this even have any sort of reference ever anywhere on the DKG? If it does, and if there are tokens associated with it for the rewards of the ones hosting them, then the nodes will do it. So it's completely decentralized, but also trustless. The nodes will not host something that that somebody just asked them to do. But long story short, you always mint an NFT from version 6, which is really great because that means all of the assets on the DKG, whatever they are, whiskey bottles, certificates of BSI, vaccines, they all in this initial creation get to be Web3 assets, and you can use them with all Web3 basically tooling that is usable with such NFTs. What is great though about that generally NFTs don't have, that the DKG assets have, is the ability to associate them with keywords. So when you do keyword search, you're able to actually find assets based on, well, search, right? Like Google. And what's great is you can also observe keywords. You can see, okay, these are the trending keywords. This is what people are looking for. Kind of like on Twitter, right? You can see that trending thing on the side. Well, that's exactly what you'll be able to see in the DKG from version 6.
It's just understanding the minting process. Once you understand the minting process, the rest of it kind of, well, if you understand the DKG stuff, it kind of just flows together. But I just didn't understand that you were minting that NFT every single time. So yeah, that just, wow.
It's an evolution. It was previous versions of the DKG. There were also, you can observe an NFT as a blockchain record. If you just look at it from the data perspective, there's a hash there, there's something, like a ownership property, and that is the data mindset, right? And then when we actually went towards V6, we completely changed not just the tech, we changed the mindset of the team. And I think now what will follow is the mindset of the ecosystem is also changing from this data to assets. Because all of a sudden it's not just data, we just didn't put some hashes on chain and we actually created NFTs out of them. And all of a sudden this whole cloud of things, wallets, NFT customized websites, tooling, all of this is now just like plug and play with the DKG. But not just that, you also have the ability that these people who are used to the data world, like for example, when you go to the semantic web community, they're like the old Web3 community. They have very little understanding of the notion of ownership, something which is very inherent to, let's say, us as Web3 people. This piece of data is like a piece of land as an asset in a wider network or really wider graph of all connected things or assets. And then when I have a physical asset represented there, I can do many more powerful things with it, share it, fractionalize it, discover it. Like even that just enterprise use cases are very often 80% just discovery, finding where things are and what they're connected with. To them, it saves a ton of hassle, ton of money. It gives them much more power. Like for example, this trust application that works with the DKG. That's literally the first of its kind in the world, I can say, which tracks all of these medical things, basically vaccines, pills, you name it, based on standards, based on the graph, and based on Web3 assets in the DKG. And it's incredible, really, how it works. But it's okay, easy for me to brag about something we built. It's really a discovery case, So for them, it's not so important that it's NFTs, but for you, it could be very important that you have very verifiable record issued by somebody who's administered, for example, this pill or drug to you, and you have everything as kind of a medical record. That's the other side of the world, the enterprise side of the world. But when it comes to just going into the NFT space and all of these booming things, and even the Traverse project, which when you told me more about it, I was amazed about the idea. All of these new combinations, audio, visuals, and all of these things, the basis of it is a connection, and graphs are great for that. So if you create those as Web3 assets, if you have those assets on the DKG, for example, those profile cover images, that's it's a completely new field, and there's a lot of things to explore there. And the graph gives it's like a really good tool for this. That's the least I can say.
Gotcha. So I know I only had you for an hour, and I got you 10 minutes over that schedule. I thank you for that. I do have, of course, I think I have one more question for you. I have more, but I don't want to waste any more of your time. But
well, it's fine, man. We can go for a bit longer.
All right.
I'm enjoying this.
Oh,
cool.
Okay. All right. So when it came to well, I guess if I'm currently working on Trackverse, and other people are working on different things in the ecosystem right now. We have people building games and stuff. When they're ready, they'll talk about all of the stuff that they're doing. But so let's say these people wanted to launch an early launch. Is there something that they should be waiting for? Should they be waiting for? Is it okay for them to say, okay, well, I'll launch my initial set on Ethereum, or I'll launch on Polkadot, or on Moonsama, or whatever, and then wait to integrate? Or are you recommending that people just kind of hold out their project ideas to release everything on OriginTrail's Parachain itself?
That's a very good question. Depending on the project, of course, probably different answers. But when it comes to if you're doing something that you want to use the DKG for, obviously it makes the most sense to do on a blockchain that is connected to the DKG. And the first one that is going to be with the version 6 is Parachain, but relatively soon it's going to expand to all the other supported chains that have been adopted so far. So for example, if you're working on, I don't know, a game that's going to use some NFTs from Polygon, and this game has a sort of smart contracts, let's say, that are part of the game, it makes sense that you use DKG with Polygon, with those assets on Polygon. So like the contracts of the DKG are kind of your bridge between that blockchain ecosystem and the DKG. For Polkadot, you can do anything on any chain, pretty much. The difference is like the performance. So for example, a cross-chain transaction in Polkadot is not the same as one transaction on one chain. It's a little more complicated, and therefore a little bit more, so if you need a lot of these, you might, like for example, if you want to do a lot of things on the DKG and there's some assets on another chain, it makes sense to do it, to index them on the DKG and then do pretty much everything on the Parachain and the DKG. But if you need to do something also on the other chain, you have the possibility to use with XCM. On the other hand, if you really need to really tightly integrate with a specific other chain, deploy your application as a kind of a cross-chain app in Polkadot. So there's multiple ways to do things, and they really depend on what you exactly try to achieve. As kind of a technical piece of advice for anybody building such things, it's really good to create some sort of a specification. It doesn't have to be like a really boring old school 200 pages specification, but like if you create a couple of pages of like, some diagrams, like block scheme, a sequence diagram. Sequence diagrams are probably the best tool. We use them a ton in Trace Labs. And user stories, they're also really good. You don't have to like have a user be a person. You can say, I don't know, NFT does this when I do that. It's a really good tool. When you have a bunch of these, things become clearer, and then you realize, okay, I need like a lot of quick transactions which are directly related to this specific token on a specific chain. Okay, I need some contracts there, or maybe not contracts, maybe some specific functionality on that chain. It becomes obvious, or very clear, at least, maybe not fully obvious. And what I can say is, since you mentioned people are building all kinds of cool things, that sounds amazing, guys. If you are going to be building games and things like that work with the DKG, absolutely use Discord, share this with us. Like, we can totally give you feedback. If let's say you share a diagram and you say, hey, is this the right way to use the DKG? This is something we'll be super happy to provide feedback on and help, because this is it's probably not like an 8-hour session that we can sit together and build these things together. But if you guys throw something out, like you or any multiple or one person, whatever, we'd be happy to see it and give some comments, to the extent that of the time that allows. But like, if you can concisely and clearly like point out, this is what I want to do, not just like a vague, cloudy description. Cloudy things get vague and cloudy answers, right? But like, if you go architectural, if you write a sequence diagram, if you sort of explain this thing does that and so on, we can totally pitch in and assist.
I guess the neighborhoods, you had the RO sets and you had R1 sets and R2 sets. I just want to get your opinion, because even though you did talk about this in the AMA, for the builders here, for the node runners, there were some concerns about, what if I have 10,000 track and somebody has 1 million, they're going to get all the jobs. Well, you definitely explain that it's based on these 3 factors. It's a balancing act of these 3 factors. So can you talk a little bit more about the choreography between winning jobs and publishing and whatnot?
Sure. So basically, let's start from the high level. So you publish to the DKG. this asset graph that previously, like I said, you minted an NFT for. Under the hood, this happens. You send a transaction to the blockchain, this mints an NFT, it stores all of the necessary information, then that actually gets published on the DKG. And then the nodes on the receiving end, there's actually a group of nodes, the neighborhood or a shard, that are chosen based on the proximity. And this is kind of the key thing in the DKG. Basically now in the version 6, you have this notion of address space. That's this first criterion of the 3 in the RFC. Criterion 1 is key space proximity. That's how it's officially called. Second one is obviously the price, and then the stake. So basically, this request gets directed to this particular neighborhood or shard. What is a neighborhood? Well, if you imagine address space is kind of like a street. Imagine a very, very long street, and the house at the beginning is number 1, and then in the end is like, I don't know, 1 billion something, right? Have a billion houses in between. You can consider that like a very long street is like a city, whatever. And then if you take like 20 houses that are next by, they're like a neighborhood. But any 20, you can sort of point into, I don't know, house number 523, and then like the 10 to the left and 10 to the right are basically its neighborhood, right? So what we do here is we actually take that asset graph and we sort of create an address for it. That's what you do with this hashing. It happens so that all of the houses, all of the nodes in the network have some address, which is in the same address space as the asset graph. So not to confuse everybody, long story short, think of just like literally the asset determining a certain address where it needs to be. And why does this become one of the core things is because whenever you're looking for an asset, getting it, querying it from the graph, you're going to be looking at the same space. So it's kind of like a protocol for everybody to agree where to organize things. Let's say another analogy would be a library. Back in the day, you would go in the library, the librarian has these like bunch of boxes, and you tell them you want a book, I don't know, Moby Dick, whatever, and she's going to go look, or he is going to go look at the M letter, and then I don't know, it says that shelf and whatever, so they kind of have to navigate through some sort of system of categorization, or better said, an index. Well, this address space in the DKG acts like an index, but it's very abstract. And because it's very abstract, it allows us to extend it in many ways. So the neighborhood in this, for example, in this example, is using one key space. But in the future, we intend to introduce multiple key spaces, like this vector search that I mentioned. So all of the nodes, they will have multiple streets that they lived in. Think of like a crossroad. So your house is on a crossroad, and it kind of has addresses of both streets, let's say. And imagine like an infinite crossroad, so some sort of thing like that. But basically, the neighborhood gets determined deterministically, but also randomly based on this particular hash. And then in this neighborhood, the nodes that are there, they're the ones that can provide service. Now, let's say somebody is trying to be too cheap and not spend enough tokens. Well, none of the nodes can then, in that case, if it's below what they're asking for, can accept this, and this publishing just fails. Because nobody wants to provide the service at this price, just as any market, right? So the publisher has actually a feature to get a kind of a suggested bid. It actually reads all of the prices that are requested from the nodes in that neighborhood, and it forms its offer. Its offer is based on, kind of like when you go to MetaMask, you can do like medium, high, low for a transaction fee. When you do low, it's probably going to last very long, maybe never gets mined, depending on the network conditions or the market conditions, really. Medium is safer, high is like it's going to happen in like a block or two, right? Similar approach. So you're going to have medium, low, high for the DKG, and that's based on all of the prices in that neighborhood. And now, basically, when this second criteria gets satisfied, that means enough nodes are happy with the offer, then the third criteria is just used, the stake criterion is used to sort them, but not just by stake. Actually, the first criterion still applies. So what does that mean? if I have a neighborhood of 20 houses, and let's say in the middle of the neighborhood is like the smallest distance, because that's how you look at it from the data. So the data key proximity distance is calculated from this address of the data, which is a number like, I don't know, 518, and the closest house is 519 in this case. 527 is also close, but it's not as close as 519, right? So there's a formula, and you're going to be able to see it in the contract, the formula that basically looks kind of like this. It's what's the word in English? Okay, I think I'm getting tired. When you have when you divide two numbers, but you write a horizontal line, what is that called? Like A over B? Fraction, yes. Sorry, not my first language. Anyway, so imagine a fraction, and very simple fraction that says, if you have more stake, you have higher likelihood to get ahead. But also, if you have if you're closer, you also have a higher likelihood to get. So if your distance is smaller from the data in this key space, you also have a higher likelihood. So in order to implement this, the fraction says like this: if stake grows, so should the chances. But if the distance grows, the chances should diminish, right? So on the upper part of the fraction, I forget what it's called in English, is a factor of stake. Basically, there's a formula that is the input for it is stake, and the lower part, the one that you divided, is the distance. So the higher the distance, the bigger the number you divide with, and it diminishes your stake. So it's a continuum. It's not like, 20 nodes get chosen, then some of them are happy with the offer, and then out of those, whatever they're left, the 3 with the top stake win. No, because that would always be the same 3. That's the wrong approach. And actually, that's not efficient in terms of network. But because back to that neighborhood thing, the difference between let's go further a little bit with an analogy. Let's say we build a city from scratch now, which is the V6 network, and nodes start popping up on this long street. They will actually position themselves randomly on this very long street. The street is incredibly long, randomly around the street. So essentially, if you physically think of neighborhoods, the houses will be very distant from each other, like miles, hundreds of miles. But over time, as new houses, new nodes come in, they sort of fill up the space in between, right? So what happens is, what's the neighborhood today is going to be different 6 months from now. There's going to be more nodes joining the network until at some point it gets to some sort of, let's say, equilibrium, I guess. But like there will be new nodes joining. So what can happen is that kind of a neighborhood slip can happen. If some data is early on there, like published asset on DKG, and then all of a sudden a bunch of new nodes are in this neighborhood, then querying in this neighborhood, which is the new one, which is determined by the same algorithm, might actually not find the asset if the system was not implemented well. So if we only looked at stake and not at the changing neighborhoods, at the distance as being the primary factor, then the whole system will break apart. So what has to happen, and that's why this is the first criterion, and the price and the stake is the second and third. What has to happen is, as the network grows, the new nodes joining neighborhoods, they actually sync with their neighborhood. And what can happen is, let's say you join the network after 100 nodes. You're the 101st node, and you're in a certain neighborhood. Your node gets a bunch of data, and all of a sudden you realize, okay, I can monetize this because I'm hosting part of the network. But because of the neighborhood I'm in, I see like everybody has 50K, whatever trace they need. I can go with 50K. If there's people who have a little bit more, that doesn't mean that this is gonna like make you have to up them, a little bit. All that has to happen is that the data comes closer to you sometimes. And in this particular implementation, the first key space that comes with version 6 is it's a random distribution, uniform distribution. So the likelihood of something ending up in an area around you is completely the same around the whole network. And that changes with when we introduce similarity, for example, and new things into the network. So that's going to be a bit different, but the tokenomics is going to be pretty much the same. It's just going to be a bit different on how the rewards are going to be designed. But for the first version, basically, there should be no concern that one node has 1 million trades staked and it takes all of the things on the network. No, because first, it's not part of all of the neighborhoods, and even when it is, it has to be that a bunch of other nodes, actually majority of other nodes in that neighborhood, are going to be closer to the majority of things that fall in that neighborhood. You know what I mean? So it's kind of like a sweetener. If you have a node, and you increase your chances with a higher stake. But it's not that you blanket win everybody and you're just like KOing everybody in the network. That would be stupid. I mean,
yeah, absolutely, which is why there was such an outroar. But I mean, I know Calvin and I, we spent some time battling people, telling people yes, pretty much it's not going to be the highest stake wins, because first of all, that obviously centralizes the network. Yeah, so honestly, I just feel really excited because you've given some really good context for some good answers, I guess, for some really impactful questions that the community had as well. And also for the devs that tuned in today. It's just not every day you get to speak to someone of your caliber. And well, you always act surprised like you're no one special, but dude, you're pioneering the world's first decentralized knowledge graph here. Let's be real. Like it's a big deal. It's a big deal. So
it is. Thank you for all the compliments and for the opportunity, man. I love to share. I think fundamentally we're also building this because we're that kind of people. Information and knowledge should be shared, and I'm really happy to be able. If anybody learned anything today, I'm super happy. So that's my mission, not just by building tech, but also, I guess, in life. So happy to do as much of these as we can squeeze in when we have time.
Of course, and that's the main aim, to do it whenever we have time. This is a no pressure, no requirements, no stress zone. This is just something that I wanted to do for everybody that is following me in my dev path. Everyone else, you will have the exact same opportunity as me. So we're all starting from an even grounds here, and we all want to build on the DKG and do the best we can to heal this globe. So Brana, thank you so much for coming through. I really appreciate you as a dev and as a brother and friend. Giga stopped by this morning just fill in for a little bit. I thank him too. I see Yuri, even Yuri is here. We have the OT team here. You know what? You guys should just come and build for my project. How about you guys all come work for me? How about that? No, I'm just kidding. All right.
Let's do it. We just have to be in the same neighborhood, right?
Right. You know what? Thank you, Brana. Thank you, everyone, for coming. And stay tuned for the next piece of content. I love you guys. If anyone wants to ask me any questions, feel free to stick around and ask around in the AMA chat. And Brana, feel free to go enjoy your day. Have a good time.
We're gonna go grab some dinner and maybe a beer. And yeah, you guys, thanks for coming in. It was great to chat here. Also, maybe just like final piece of info. If any one of you is running DKG nodes on the testnet, we just released like an hour ago or so the latest release. It's actually quite big because it uses the new trace, the Polkadot native deployment that was done on currently the Parachain DevNet. So you can even try it on Polkadot.js. You can send a bunch of tokens. If you have a node, it already has been funded. We went ahead and did that, so it's easier for everybody. But do make sure that it was updated because it was a breaking change. And we've seen a few glitches on our environment, but usually on the testnet, it's much more colorful. Let's say it like that. There's like people hosting different things in different places. So if you see any issue, we would super be happy to get some more context or info from you guys. This also implements the minimum 50K stake, so that we were over the hump with this release. And there's a new, actually, what we just talked about, the 3 criterion. this sharding table, which is used in this case, is actually implemented. We're still polishing bits and pieces, but this was a really major change. And one great thing about it is it's minimizing the dependency of libp2p. So we're basically mostly backed now on the network level also by DKG code. Probably not so relevant in terms of like node running, but it's actually quite a big release. And then from this moment on, there's only a few things that we're introducing one by one, step by step on the network, on the testnet before we go to the mainnet. So the mainnet is really close. Yeah.
Yep. And if there's any experienced devs in the call right now, feel free to reach out to the team. They are hiring.
Yes, very much so. We're looking always for excited people about what, things like what we do, graphs, Web3 in general, or if you're just like, you asked at some point what we're looking for. I never answered that, so I can answer it now and we can close the call. We're looking for people who are excited to build great things. And if you don't know a lot of things, if you don't you have to have some basic level of knowledge, like English and some computer science, of course. But like if you have the excitement and if you're willing to learn, there's usually something we can give you to do. So there's a lot of teams, actually, a lot of people in our team who came to Trace Labs as interns and today are leading projects because they learned in this environment. You can learn a ton, but you have to have the right mindset. If you're not excited about Web3, it's not. We're not a place for you. But yeah, it's all about that. And I mean, like the atmosphere we have right now, that's the same atmosphere we have in the company. Like, we're just random people who work together and are really excited about this cause.